All right, ladies and gentlemen, today we are doing lesson 1.3. That means module 1, lesson 3, for those of you who are keeping track at home with the practice at home. Your learning goal today is to be able to use exponents, and we're going to talk about what exponents are, to name place value units, and also to look for and describe patterns with different numbers with different kinds of decimal points. Okay? Okay, once you've found the lesson 3 template in your workbook, we're going to fill this out together. Do you guys see on the very right-hand side how it says 10? Okay, 10 is equal to 10 times what? 1. Okay, very good. Go ahead and fill that in. Okay, what if I give you the number 100? Go ahead and write 100 up here. 100 is equal to 10 times what? 10. Okay. Now over here, if I have the tens, the hundreds, what's the next one going to be? 1,000. 1,000 is equal to 10 times 10 times 10. Would you agree?
Yeah.
What's the next adjacent place value going to be?
10,000.
10,000. Okay, let's write that at the top. And how many times do I have to multiply 10 to get 10,000? That'd be 10 times 10 times 10 times 10. Okay. What's the next adjacent place value? 100,000. Let's write that up at the top. And how many times do I have to multiply 10? 5. So it'd be 10 times 10 times 10 times 10 times 10. 5 times. Okay, the next adjacent place value is 1 million. Go ahead and write that down. Okay. And how many times do I have to multiply 10 to make 1 million?
6.
Okay, go ahead and write 10 times 10 times 10 times 10 times 10 times 10. Okay. I want you to talk to your table group. What patterns do you notice about what we just filled out so far? You know, as I was walking around listening, I noticed someone said, or I heard someone said, over here there's 1 0, over here there's 2 zeros, 3 zeros, 4 zeros, 5 zeros, and 6 zeros. Each time you move to the left, you're adding a 0. Someone also said, every time you move to the left, the number's getting 10 times bigger. So when we add an extra 0 at the end, the value is getting 10 times bigger. Because over here there's only 1 10, here there's 2 10s, 3 10s, 4 10s, 5 10s, and 6 10s. So what do you notice about the number of times you have to multiply 10 in relation to how many zeros there are? Jaden? So each time we multiply by another 10, what happens to the product? It gets 10 times bigger, and there's another 0. At the very bottom, let's write down how many times we had to multiply by 10. So for 10, how many times do we have to multiply by 10? 1. What about for 100?
2.
What about for 1,000?
3.
What about for 10,000?
4.
What about for 100,000?
5.
And what about for 1 million?
6.
6 times we multiplied 10 by itself to get to 1 million. I want you to write this down in your notebook. Today we're learning all about exponents. And exponents is a little number that tells you how many times we use a factor. And in this case, 10, because 10 is the base number. Okay, so this is the base number. And this is the base number. Okay, so once again, the exponent tells you how many times you use the base number as a factor. So in this case, 10 is the base number. So in this case, our exponent is 5. So how many times would we use 10 as a factor? 5 times. So 10 with an exponent of 5 is equal to 10 times 10 times 10 times 10 times 10. Do you see how I multiplied 10 by itself 5 times? Because the exponent says 5 times we will use 10 as a factor. Make sure you write this down in your notebook. So what does that equal? What is 10 times 10 times 10 times 10 times 10? Grant? 100,000. So 10 to the 5th power is equal to 100,000. So then using what we know in our chart, this is the chart we wrote just a couple minutes ago, we can write all of these numbers, 10, 100, 1,000, 10,000, etc., using exponents, can't we?
Yeah.
10, how many times did we use 10 as a factor? How many times do you see 10 in this number? Everyone? 1. So the exponent tells you that we use 10 as a factor 1 time. What about 100? How many times did we use 10 as a factor? 2. So our base number is still 10 because that's the number that's getting repeated, right? But how many times did we use it?
2.
So our exponent should be a little tiny 2. Yep. Be careful when you're writing exponents. If I write 10 to the power of 2, but I write it like this, could that look like 102?
Yes.
So you want to make sure your exponent is really teeny tiny and up in the upper right-hand corner. For 1,000, what is our base number? What number is getting repeated? What factor is being multiplied? Everyone?
10.
10. And how many times is it being multiplied? 3. So our exponent is 3. So that means 10 to the third power is equal to what number? 1,000. You got it. What about 10,000? What number is our base number? What number is getting repeated over and over again? 10. Okay, so 10 is the base number. That's the one we write really big. And how many times is it being used as a factor?
4.
So our exponent is
4.
4. So I write that by writing a little tiny 4 up in the right-hand corner. That tells me 10 to the fourth power is equal to what number?
100,000.
Is it equal to 100,000?
10,000.
10,000. Yeah, you got it. 100,000, we got that number by using what base number? 10. And we had to multiply 10 how many times to get to 100,000? So my exponent is 5. Okay. Finally, 1 million. What number did we use as our base number? 10. And what number should the exponent be? 6, because we had to multiply 10 6 times to get to 1 million. So Kish is noticing that the number of the exponent, so for instance 3, is the same as the number of times you need to multiply 10, which happens to also be the number of zeros in the value. Do you guys see that? So let me ask you, how would I write this expression as an exponent? Here I have 10 times, is 100 the same as 10 times 10?
Yeah.
Okay, so how many times, what's my base number? What number is getting repeated as a factor? 10, okay. And how many times did I have to multiply 10?
3.
So the exponent is 10 to the third power. 10 to the third power has the value of what? Everyone?
1,000.
So is this problem the same as 3.4 times 1,000?
Yeah.
And based on what we learned yesterday, do we know how to multiply something by 1,000? We could do 1,000. We could multiply something by 1,000 in 2 ways. We could move the digits to the left, or we could move the decimal point to the
Right.
Okay, let's do the decimal point way. So if I multiply 3.4 by 1,000, will the number be getting bigger or smaller?
Bigger.
If I give you 1,000 times of something, will you have more or less?
More.
More, right? If I give you 1,000 times of tests, would you have more tests or less tests? More. So is this number getting bigger or smaller? In order to make 3.4 bigger, do I have to move this decimal point to the left or to the right? Right. Okay, and how many times will I have to move it to the right?
3 times.
Okay, so if I have 3.4, and I'm going to move this decimal point 1 time to the right, 2 times to the right, 3 times to the right. Now my decimal point is here. What do I have to do to those blank spots?
Add zeros.
Okay, so 3.4 times 10 to the third power is going to equal to what value? 3,400. Very good. So do you see how we can take what we know about exponents and combine it with what we learned on Monday and Tuesday?
Yeah.
Very good. Try this one out. 7.1 divided by 10 to the second power. Wait, but 10 to the power of 3, that you disagree that equals 30?
Yeah.
I want you to step into the shoes of a math teacher really quickly. What mistake do you think this student made if they said 10 to the power of 3 is equal to 30? Talk at your table groups. Yeah. This student might have thought this means 10 times 3 equals 30. But is that right?
No. The answer should be 10 times 10 times 10 times 10 times 10.
Very good. Okay, so this is a very common mistake. Often in class, I will tell you about common mistakes that 5th grade students make. Because if you know about a common mistake, does that help you avoid it? It's like if I tell you, oh, there's a giant hole in the road over there, so don't go over there. Do you think you would avoid the hole? But if you didn't know about it, might you run and all of a sudden fall into the hole? Okay, so I'm telling you that this is a very common mistake. Oftentimes, students who don't have Miss O as a teacher will do 10, they'll see this, and they'll think it equals 10 times 3. But it's not. We know that it's 10 times 10 times 10. That in this pattern up here, you always have a 4 followed by a 3. Is it the same digits in the same order? But the value is being changed, huh? What's happening to this decimal point? How many spots over did it move?
2.
And then from here, how many spots over did it move?
2.
So if the decimal point is moving over to the right 2 spots each time to make the next number, as Ritvik said, what's happening to the number? It's getting multiplied by 100. So what would be the next number here? I would have to multiply 430 by 100, huh? So I'd have to move the decimal point 2 more spots over. What number would be next?
43,000.
43,000. What number would be after that?
4,300,000.
Oh wait,
4 million.
it was 4 million? Okay. 4,300,000. Then what would be the next number? 430 million. Very good. So do you guys see how there's a pattern? What's happening to the decimal point each time? It's moving 2 more spots to the, because we're multiplying the value by 100. Try this one in your notebook. Copy down what you see first, including the blank spaces, and see if you can figure out what's happening and how to fill in the blanks.